Test network latency with Ping and Traceroute. Use this topology, your PC connected to your router, connected to internet. To obtain realistic network latency statistics, this activity must be performed on a live network. Be sure to check with your instructor for any local security restrictions against using the ping command on the network. The purpose of this lab is to measure and evaluate network latency over time and during different periods of the day to capture a representative sample of typical network activity. This will be accomplished by analyzing the return delay from a distant computer with the ping command. Return delay times measured in milliseconds will be summarized by computing the average latency, mean, and the range, maximum and minimum of delay times. Required resources: only your PC. Instructions: use ping to document network latency. You will examine network latency of several websites in different parts of the globe. Verify connectivity. Pick the following regional internet registry (RIR) websites to verify connectivity. For example, ping www.lacnic.net, okay, for Latin American, africnic.net for Africa, and abnic.net for Asia Pacific. Because ripe.net and erin.net do not reply to ICMP requests, they cannot be used for this lab. Okay, ping www.lacnic.net. Open the command prompt. Ping www.lacnic.net. Enter. Okay, you can see I'm using IPv6. Okay, reply all very good. And if the websites are resolved to IPv6 addresses, the option 4 can be used to resolve to IPv4 addresses if desired. Okay, and you can use the option 4 for IPv4. Okay, repeat the same command but add the option 4, and you will use IPv4 for the ping. Okay, very good. And ping www.afrinic.net and apnic.net. Okay, you can use IPv4 or IPv6. You can use any. I will use IPv6 for afrinic.net, www.afrinic.net. Okay, this is IPv6 ping to afrinic. An example using IPv4 for apnic, apnic.net. Success. Collect network data. You will collect a sufficient amount of data to compute statistics on the ping output by sending out 25 echo requests to each address listed in step 1. This step may require administrative privileges depending upon your operating system. Record the results for each website to text files. Type ping to list the available options. Only ping. Okay, ping. Now you can see all the options. For example, one option is option N, count number of echo requests to send. Okay, by default are 4 echo requests, but you can modify that value using option N. Use the ping command with the count option. You can send 25 echo requests to the destination as illustrated below. Okay, ping option N, 25 pings, 25 echo requests to this destination. It will create a text file with file name in the current directory. This text file will contain the results of the echo request. All the results redirected to a txt file. Okay, only repeat this command. I will use IPv6. If you want, use IPv4, no problem. You can use any. Ping, option N, 25 counts, ping, N, 25, destination www.lacnic.net, and redirect to lacnic.txt file. Enter. Okay. The terminal remains blank until the command has finished because the output has been redirected to a text file, lacnic.txt. The greater than symbol is used to redirect the screen output to the file and overwrite the file if it already exists. If appending more results to the file is desired, replace greater than with this double symbol in the command. Okay, and very good. Now you can see the command prompt again. All the output was redirected to the file, and go to this directory. C users 0 in my case. Okay, C users 0 and you can see this file lacnic, and you can see the results. 25 pings, 25 echo requests, request timeout, request timeout. Packet sent 25, receive it 23, lost 2, 8% lost. Minimum 250 milliseconds, maximum 2222 milliseconds, average 408 milliseconds. Very good. My statistics for this ping using IPv6. And now, the same process with afrinic and abnic. Okay, only repeat the command and modify the name. afrinic.net. The file should be different. afrinic.txt. 25. Enter. And wait a moment. Okay, review the file. Now you have this file, afrinic. Okay, it's not finished. Close this. Okay, now you can see the command prompt. That mean uh, that means is finished. Okay, enter again. Now you can see 25 pings, send 25, received 25, lost 0, lost 0, 0% loss, minimum maximum average in milliseconds. Okay, and the same process for APNIC, Asia Pacific, and the text file should have a different name, APNIC, enter. And wait a moment. And now you can see the command prompt. And you have this another file, APNIC, and you can see the results. Very good. Verify data. Okay. Use your command to list the files in the directory. Also, the wildcard can be used to filter only the text files. Okay. Dir all with txt extension, all text files. Now you can see your three files, three txt files. To see the results in the file created, use more commands. Okay, for example, I want to see lagnic.txt and use more lagnic.txt. Yeah, you can see the results. Record your results, minimum, maximum, average. Okay, in this case, minimum, maximum, average. For afrinic, minimum, maximum, average. For apnic, minimum, maximum, average. Compare the delay results. How is delay affected by geographical location? Okay, I am placed on Latin America. Now I am on Peru, here on the green section, Latin America. And this is the ping for Latin America. Okay, and the average for Latin America is 408 milliseconds. So for me, ping to Lagnic is very close. Okay, very close to me. 408 milliseconds. But Afrinic is placed on Africa, the purple section. And I am placed on Latin America. I am the source, and the destination is Africa on the purple section. And the ping is 582 milliseconds. Okay, obviously it's a higher value. And for Asia Pacific, APNIC, Asia Pacific, is the another destination. I am the source placed on Latin America, and UPNIC is the destination. And review, only the average is 173 milliseconds. Okay, it's very close to me because the Earth is a sphere. Okay, the ping can go using the Pacific Ocean on my left and reach this yellow section very close. Okay, and the answer here is the response time is longer when compared to the physical distance to the destination. More distance, more geographic distance cause more delay, more milliseconds. Okay. Use traceroute. The routes traced may go through many hubs and a number of different internet service providers depending on the size of the internet service providers and the location of the source and destination hosts. The traceroute command can also be used to observe the network latency. The tracer command is used to trace the path to the same destination in part 1. The command traceroute is the Windows version of the traceroute command. The tracer command uses ICMP, TTL, time to live, exit packets, and ICMP echo replace to trace the path. Use tracer command and record the output to text files. Use traceroute the destination and redirect the output to a text file for the same destinations. If you want to use IPv4, use the option 4. I will use IPv6. Tracer www.lacnic.net redirect to traceroute underscore lacnic.txt. Enter and wait a moment. May take a while. You can see now you will have this file traceroute underscore lacnic, and you will see it's not finished. Close this and wait. Okay, now you can see the command prompt is finished, and review this file again. Now you can see 16 hops, 16 lines. That means 16 hops. Most of these hosts are routers. Okay, maybe this is the server, the destination server using IPv6. Okay, the first hop is my router, my local router. Okay, and this is the IPv6 address for my default gateway. Okay, no response, no information for hops 2 and 3. and this is my internet service provider. But this is the name of the destination, and this is the IPv6 address. Name, IPv6 address, name, IPv6 address. Okay. In some cases, only the IPv6 address, and for the destination, the final destination, www.lacnic.net and IPv6 address. Okay, I pass it through 16 hops to reach the final destination. And repeat this for afrinic and apnic. Use the more command, okay, and use more command to examine the file. Okay, for example, only use this more, and the file name traceroute underscore lacnic.txt, enter, and now you can see the same result, the 16 hops. For example, use 3 pings. The first less than 1 millisecond, the second less than 1 millisecond, and the third less than 1 millisecond. Okay, for number 4, the first ping 36 milliseconds, the second for 34 milliseconds, and the third 34 milliseconds. Okay, average is not shown here. You need to calculate the average of these 3 pings. Okay, for example, for hop number 7, the first delay is 537 milliseconds. The second delay value is 147 milliseconds. And the third delay is 144 milliseconds. So the average is not shown here. You need to calculate the average of these 3 values. To calculate that, only do this: 537, 147, 144, and 3. This is the average, 276. Okay, this is the average. Okay, so you can see 36, 141, 160, 537, 146, 247, 252, and okay, and you can see the further the destination, the delay will have greater value. Okay, perform the same analysis with the rest of the trace results. What can you conclude reading the relationship between the round-trip time and geographical location? The response time is longer when compared to the physical distance of the destination. Extended trace route. Reverse name resolution, resolving an IP address to a domain name, can add delay tracer results and yield inaccurate results. Okay, use the option D. Okay, the same command, but use the option D. Okay, repeat the command tracer to this destination www.lacnic.net and redirect this to a file, but the file should be different name for the file, traceroute underscore d underscore lacnic.txt, and use the option D for traceroute. And modify this line. Traceroute, use option D, www.lacnic.net, traceroute underscore D underscore lacnic.txt. Okay, different names, different file name, enter. Okay, wait a moment. Okay, review the file. You can see this new file, traceroute d lacnic. Okay, it's not finished. And wait a moment, close this. Very good. Now you can see the command prompt. You can see the file here. Now it's completed. Trace complete. 16 hops. Close this, and you can use the more command to view. Okay, use the more command to view the results on the file. Okay. More space traceroute underscore d underscore lacnic.txt. And okay, I'm sorry. Enter. Okay, now you can see the results. 16 hops with this is the result with option D, and this is the result without option D. You can see the difference. You only have IP addresses, only IP addresses. Okay. With option D, only IP addresses. Without option D, name and IP. Name and IP. For example, traceroute, only traceroute, and you can see the option D is do not resolve addresses to host names. What is different about the tracer output when the D option was added? The answer is traceroute using D option does not resolve IP addresses to host names. Okay, and don't forget to do this the same process for AfriNIC and for ABNIC. Reflection questions. The traceroute and ping results can provide important network latency information. What do you need to do if you want an accurate baseline picture regarding network latency for your network? You will need to perform careful delay analysis over successive days and during different periods of the day. How can you use baseline information? You can compare baseline data against current data to determine if there has been a change in network response times. This analysis may assist with troubleshooting network issues and scheduling of routine data transfer during off-peak hours.